And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, coming at you from the smAsho bunker. Today we'll be talking about solar filaments. A minor coronal mass ejection strike has just occurred. And please don't forget to press like and subscribe. First thing we're going to do is look at the sun in the colorized magnetogram view here on the browse data portion of the SDO website. And we don't see any sunspots. That area where we showed you a tiny umbra yesterday did not grow, and it must have magnetically degraded a bit. We don't see sunspots. Let's take a look at the LASCO C3, and we see some more solar ejecta in the Earth-facing mode here. So more minor coronal mass ejections have kicked off in the past day, and you can see plasma on both sides of the aperture here, an indication that it is headed our way. I would expect that to take at least 2 days to arrive, although there might be some higher speed bits in between. So expect to see some more coronal mass ejection strikes in the next 2 days. And the LASCO C3 is part of the SOHO spacecraft located at Lagrange point 1, which is L1 here. Next, we'll look at Lagrange point 5 to see what was going on at stereo A. And again, that's down here, looking in this direction, where the Earth would be off to your right if you were at Lagrange point 5. And so you can see that ejecta there, sort of at the beginning of the video. And there still is possibility for additional coronal mass ejection, so the coronal mass ejection watch does not end yet, as we've got significant plasma filaments both in the southeast and in the northwest. Again, that's located at Lagrange point 5, shown there as L5. The radial flux of the 2800 megahertz variety, otherwise known as the 10.7 centimeter radial flux, at 73 solar flux units. There's the 1 year chart of that, courtesy solon.info/solar. And there's cycle 24 shown in sunspot number and radio flux. You can see how proportional those two measurements of solar activity are. Get them both on the screen there at the same time. There you go. And next we'll look at a composite image here. This is 335, 193, and 94 angstroms, all in one view. Another great feature of the SDO browse data portion. And if you want to pull these up, just click on data, browse data. Of course, we've got some great Helio viewer movies, as we always do. And we're going to break out this one real quick. We did a close-up of the southern coronal hole region, and we'll let this play through here, as I wanted to break out a close-up of that south solar polar coronal hole. It's quite well defined right now, so let's take a moment to give it a gander. Great view of that. We've included the Earth scale as well. And coronal holes give us important insight into the solar magnetic fields, their migration, sunspot progression, solar cycle progression, etc. Here's a full disk view in the same wavelength here. It's 193 angstroms. And we've got some close-ups of those filaments. You can see pretty much on opposite sides of the sun there, one large filament in the northwest and one large filament in the southeast. We'll get to it at the end of the video. First, lots more data to cover. And thanks for leaving a comment, Life Force Rejuvenation. ARF to you too, sir. Today we're going to truncate the Smash Lights segment. We don't need to do no stinking Smash Lights segment, but if you haven't checked out the playlists, we've got a bunch of them at youtube.com/smashamash/playlists. Check it out. Smash Lights is one of those segments. And we've actually recently made an additional playlist called the Smash Hole of the Week. If you haven't checked that out, thanks for leaving a comment. JapDX as well. And we are streaming live to Twitch right now. It's twitch.tv/smashamash. Perhaps check out their free mobile app, as it will give you notifications when we go live. Don't forget to check out our own websites as well. smashamash.org, smashamash.com. You can find all of our social media as well as our VoIP line, email address, etc. in the upper right. And you can find two stores as well as the smAsho forum. We'll talk about the forum at the end of the video. Today's store is the smAsho store. Or is it the Smash store? It's the Smash store. That link right there. And today's featured shirt is the Condensed Matter Matters shirt, which shows you an image of the sun in 304 angstroms, as well as a lattice structure underneath, as if the sun is upheld by a real structure and has a real surface made of things like, liquid metallic hydrogen. Anyway, this one's in blaze orange because nothing says don't run me over or shoot me like a blaze orange shirt. Other products on that store include the Smash Team shirt and the 3C405 Bagashov edition shirt. Also our smAsho logo and our Condensed Matter Matters mask. And please take a moment to break lesson over the tube. Allow me to learn how to speak the English language and invite you to press like and subscribe on YouTube. We've also got links to the Teespring stores there as well as our Patreon. Don't forget to check us out on Twitter as well, as our followers on Twitter keep fluctuating between 120 some and 115. Now we're down to 115 because reasons. So if you're on Twitter, if you haven't been banned yet, we've got 4,444 tweets. We're also on BitChute, thanks to our BitChute subscribers. And if you're not subscribed to BitChute, make sure you do so and check out our 300 subscriber Snarkfest, a 8 == capital D do the math big tech / BitChute exclusive. BitChute.com/smashamash. And we're going to talk cosmology in a quick moment. Thanks for leaving comments, everybody, including Kathy Garden as well. So we're going to talk cosmology in a moment. First, I'd like to thank our patrons, a true source of funding for the content. Please consider becoming a patron at patreon.com/smashamash. Look for some uploads coming soon, folks. We're going to include some music only available as a patron. And the higher of a tier you get, the more likely you'll be to get some original tracks. And you can find other original music in the links below the video. But please consider funding us, as we need your help to keep these videos free, in existence, and publicly visible at patreon.com/smashamash. And patrons are listed in order of lifetime contribution. Next, we're going to roll a die to get a random number between 1 and 1031. Why? Because the Neil Gorell Swift-Bat X-ray Observatory, of course. It's got 1031 objects on it. And today's random quantum number is 177. So let's see what we've randomly picked this time. Today's random object is RxJ0531.2-6607, which is a high-mass X-ray binary / neutron star. So let's take a look at the X-ray output of this radio source. And there is the X-ray output of that. You can see it's pretty similar to the galactic core in terms of its lifetime X-ray output there, not too dissimilar from Sagittarius A star, the massive radio source at the core of the Milky Way galaxy, rather. And here is the daily output from it. It's quite a consistent X-ray source. And let's take a look at what's going on with it, visually speaking. Here it is on Simbad. And it looks like a heaping helping of nothing on Simbad. Let's look at Aladdin Light. Let's check it out on the 2-mass infrared light. And there you can see a little blur near where that radio source is located, perhaps a jet or something like that. Let's see if it shows up on Chandra. Often the best way to look at neutron stars, and indeed not. How about the Fermi? Nope. It's all a big nope. Oh, there we go. There's a good one on XMM Newton. Looks like there could be a jet involved there, folks. I'm not exactly sure there. High mass X-ray binary / neutron star J0531.2-6609. Another catchy name. And perhaps we'll study more on that at a later time. That's today's cosmology segment. And what are grand rising BBLs? Let's move on to some more data. And here's this coronal mass ejection strike that we just saw as I did show prep. You can see right there the solar wind density, speed, and temperature of the incoming plasma all jumping at the same time. And at the same time, the BTBZ also shifting, an indication of a minor coronal mass ejection strike. The solar wind density made it up to about, I see a dot up there looking like it's around 50, but there is a fairly consistent signal there around 20 protons per cubic centimeter. That's waned a little bit. Current conditions are about 13 protons per cubic centimeter for the solar wind density. Solar wind speed 314 kilometers a second. So a very minor uptick there. And it looks like it's already waning. Looks like a minor coronal mass ejection strike. Next, looking at the KP index. It's been at 0 for the past 6 hours. Here on January 11th. And let's look at the magnetohydrodynamic pressure as visualized by the University of Michigan Geospace Model V1.5. It's all based on the space weather modeling framework. And if you want to read about how that data is derived, click on details, click on space weather modeling framework. There are a lot of variables. And shoo-wee! There's that little increase there at the end. Right here. That's that little increase in the solar wind speed and density. And that's what you would expect to see when seeing a minor coronal mass ejection strike. Next, we'll go a little closer to home and look at ground magnetic perturbations since we're living through a geomagnetic excursion. We take a look daily at 4 hours of data to see where the magnetic perturbations are happening on your earthly stations. We see some over Canada, as well as some out of the central Pacific Ocean there. And you can see evidence that the South Pole has left Antarctica and is somewhere down here south of Australia. And we've got 2 North Poles, if you weren't aware. No proton strikes. We keep an eye on this daily, as this is a rather important variable. Proton flux flatlined over the past day, 3 days, and indeed week. No major X-ray flares there. Nothing even in a B-class range. And solar activity is indeed quite low. And here are the higher highs that we were forecasting on the magnetometer. You can see these did reach slightly higher levels as I forecasted yesterday. Otherwise, pretty uneventful there on the GOES magnetometer. Let's get an idea of what may happen next with the top view ecliptic plane field plot, which is part of the National Sunspot Observatory. We call it the Gong 2 data. And this is probably one of the most important data sets you could possibly have. It's derived from 51 ground-based magnetometers, as well as ones on stereo A at Lagrange point 5, which is out here, and stereo B at Lagrange point 4, which is out there. And the Earth is solidly in the South Pole current sheet, and we will remain there until tomorrow, most likely. Keep in mind that data is 1 hour and 5 minutes old and can change with no warning. Here's the line of sight coronal hole field plot. No major coronal holes in the Earth-facing zone either, except a small one associated with the South Polar region, which we showed you early in the video. And here's a line of sight field plot, which also shows a solar magnetogram. Last but not least, we'll show the solar coronal magnetic plot. And there's the chaotic environment known as the sun's atmosphere, the solar corona. And it's pretty jumbled up right now. Not a lot to say about that. Next, looking at in-the-sky.org, I'm always interested in knowing what's going on above my head. So I face my star chart to the south and I draw in the ecliptic, shown there in yellow. And the ecliptic is the plane on which things like planets orbit the sun. If you're up before dawn, you may see the moon and Venus. And you can actually advance this, if you like, also. Check it out. And here in eastern Pennsylvania, we're expecting the moon to rise at about 6 o'clock this morning. Should be a lovely crescent moon rising over the horizon in the early morning. And yes, you can figure out what part of the Earth you're on by viewing the moon, because its rotational orientation as well as its position at a given time in the sky along with its phase. Yes, the opposite side of the planet, you see a full moon happening at noontime, whereas here in Pennsylvania we see full moon happening close to midnight. There's where stuff is in the solar system. It looks like Frito-Lay's Stranglehold may be reaching a peak right now as the Earth, Sun, and Jupiter all line up. And the Malachians of Uranus, they don't know the distinction between Uranus and a hole in the ground. Expect Trump brand tortilla chips to be distributed to the Galactic Federation soon. Trump brand tortilla chips. They'll be organic and non-GMO. They'll be the greatest and most amazing, most fantastic tortilla chips that you've ever seen in your entire life, okay? They're going to be stupendous. They're going to be amazing tortilla chips. And all of those aliens, extraterrestrials, other extraplanar entities, etc. in the Galactic Federation, they're going to love the chips, okay? They're going to think that they're the best tortillas ever made, okay? Cheers, and thanks for leaving comments, everybody. And tell us where you're located. Kathy Garden will give you some idea of whether you'll get ice. Back to data, we're going to talk electrons next. We don't see charging hazards. Here's the one-year chart of the electron flux. That's also located at solon.info/solar. And here is the electron forecast model. No arguments there. Expecting low levels of electron flux here, as we've seen low levels overall of solar activity. There's a 3-day chart of the electron flux, and you can see quite low levels. We show this daily because this one shows you the F ionosphere layer, which is right there. So around 300 kilometers, that's where the GOES 16 makes its measurements. And this also shows you things like electromagnetic radiation's penetration into the atmosphere, the different layers, the troposphere, where all your weather occurs. Here's a visualization of the electron content. This is essentially through the inner Van Allen belt up to your 12,500 mile altitude GPS satellite. Expect some GPS errors over North America once again today. You can see yesterday we saw some significant electron flux, and we see a less organized series of Van Allen belts when we see low levels of electron flux than when we see high levels of electron flux, which I would assume has to do with Earth geomagnetism, induced magnetism. Anyway, here's another diagram of the atmosphere in miles, showing you where the International Space Station is, for example, in a low Earth orbit. Next, we're looking at the geoelectric field here. And this is showing you induction into the U.S. power grid. Expect to see this more often when we see things like geomagnetic storms. This will give you some pre-notion of where you might see power issues, and you see that little increase in the solar wind speed and density caused that much induction in the system, especially places like eastern Virginia, south central Pennsylvania, northern New Jersey, southern New York. So that's interesting, and you can link to that one. That is known as the Geoelectric Field 1-minute empirical EMTF 3D data, showing you induction into the U.S. power grid. And we see some power failures here. Over 100,000 in Texas and 40,000 in Louisiana. Next, we'll look at the ionosphere layer. And this is where that GOES 16 is making its measurements, or endeavoring to, at around 300 kilometers. And we see continued anomalies here in the southern hemisphere. Fairly significant, fairly discharged ionosphere around the equator. So a little bit wobbly in terms of the ionosphere here. Here's the latest image. That one coming in at 9:45 Universal Time. And let me just go back to the chat here for a quick moment. Kathy Garden located Atlanta North. All right. We'll show some weather momentarily. First, let's talk about the lava lake. The lava lake at Kilauea, there's an 800-foot long island in there. A floating island that's formed in the lava lake. It's about 820 feet long and 440 feet wide. And that's located in the... I'm not going to try to pronounce it until I have it on the screen. That's located in the... in that one caldera. I can't remember what it's called. Anyway, Kilauea is still erupting. What is up with that? Just bear with me a moment, folks. It's the Halema Oma'u crater. The Halema Uma'u crater is where that lava lake is located. Let's see what else is erupting. Around the world, we see a bunch of volcanoes, and Shivaluch now back on the list, as the Kamchatka Peninsula has been active solidly for years. It's producing, Shivaluch is, by the way, a 19,000-foot ash plume. Sakurajima, 7,000-foot ash plume. Suwanosejima, 6,000-foot ash plume. So Kilauea, that's the western vent. Halema Uma'u crater. Not a huge volcanic ash plume from there, but things like lava flows and lava fountaining. Popocatépetl exploding, flight level 210. It's a 21,000-foot ash plume. Fuego exploding, 14,000-foot ash plume. Sangay exploding, 20,000-foot ash plume. Revenador exploding, 15,000-foot ash plume. And while we're unable to detect eruptions at Sabancaya down in Peru, please do not attempt to tightrope the caldera. Don't tightrope walk the caldera, folks. It could be unhealthful. And we need the views on YouTube. And let's check earthquakes over the past 24. No major quakes. We reported 2 6.1 magnitudes yesterday, and it looks like it's been less active in the past 24 hours, although we do see some deep quakes, such as this 4.4 at Fiji, which came in at 10:13 yesterday morning. I'm sorry, 13:55 yesterday afternoon on yesterday 1:10. It was at over 600 kilometers depth and a 4.4 magnitude. Here's a deep quake in Afghanistan. We've seen many of those. Another deep quake strikes Fiji, a 4.7 magnitude at over 500 kilometers. Another deep quake under Denali, and we've seen this the last 3 days, actually, reporting deep quakes under Denali National Park, Alaska. And we'll just scroll up the list here. Another deep quake under Denali. Small deep quake strikes western South America. And another. Japan sees a deep quake. Largest of the past 24 was at depth here, it looks like. One of the largest is this 5.6 at Indonesia at over 618 kilometers depth. Also a 4.8 in the Flores Sea at over 630 kilometers depth. So deep quakes kicking off here as the 7, 8, and 9 magnitude earthquake drought continues, folks. Deep quake at Japan. So lots of deep quakes here. And check out the jet streams of the northern hemisphere. We're looking at the geographic North Pole here. We've got all kinds of jet streams flowing in all kinds of different weird directions. Here is the jet stream view of the Western world. And check out the extreme bends over the lower 48 there. Let me just check the life of the stream here before I vanish. And everything looks just fine. Again, there's the jet streams of the Western world. All over the place in the Northern Hemisphere. A little chaotic in the south as well. Here are the jet streams of the Eastern world, as we see it blowing backwards over the Western Pacific and the Indian Ocean once again. Next, looking at the lightning mapper here on the GOES 16 lightning mapper. Not a lot of lightning there. A little bit in southern Virginia. And here's a real-time lightning map, courtesy of lightningmaps.org. I turn it on when I hear thunder. No terrestrial lightning striking in the U.S. right now. And here's a Doppler radar map. And that system taking its good old time there. We'll show you a snow forecast momentarily. And the heaviest precipitation there in southern Mississippi. As northern Louisiana sees heavy snowfall. Let's do a forecast. This is the Euro forecast. We're going to zoom in on the southern part of the country here. There we go. There's where things are currently. Nearly 6 inches of snow reported there in eastern Louisiana, as well as snow in Mississippi and so on. Not normal. Here's where we expect things to be at 12 noon Eastern time tomorrow. Pretty stagnant there. And in Atlanta, you're not expected to see snow. I'll actually let this play through here. And this is the European forecast. So it's going to be a warm, wet snow, I would imagine. There's where we expect things to be at 1 p.m. tomorrow, Eastern Time. And we're located in eastern Pennsylvania here in the Lehigh Valley. Smash staff and I are right about there. Lehigh Valley, Pennsylvania. There's what's going on in the cloud layer. It's not light enough yet to see the clouds. So we use the NASA GOES Interactive Weather Satellite 3.2 nanometer. 3.9 nanometer. Why do I always say 3.2? Anyway, there's what's going on in the water vapor. And we'll actually zoom in here on Narlands, since Narlands is pretty close to the center of the activity. We'll show you the water vapor and the cloud layer here. Just give that a moment to load. And we'll shrink it down to a better size there. There you go. So there's the situation of the cloud layer. Bunch of low clouds here over the Atlantic Ocean and the Gulf of Mexico once again. And there's the water vapor. And that dry mass of air is taking its good old time pushing through there. And there's the water vapor again. And there's the cloud layer. And it's time for bonus features, like the high-res imagery of the local yellow dwarf. We want to show you if there are sunspots, and the colorized magnetogram, as well as close-ups of some amazing filamentary activity on the southeast and northwest corner of the sun. So first things first, there's the colorized magnetogram to show you a few areas of magnetic organization. One there, and a couple there. Still looks like 0 sunspots to me. I don't know, that could be a sunspot. We'll show you the intensity gram next. And there it is. I see a minor umbra right there. So that one could get named. It could have a long enough time on the Earth-facing portion of the disk there to obtain a name. Otherwise, no sunspots. So we're still at 0 sunspots. One might get named today. And here are our final Helio viewer movies. First of all, here is the... well, let me check the chat one more time before I close this thing out. And thanks everybody for leaving comments at Twitch. So here's the filamentary behavior in the northwest region. You can see a great three-dimensional view of that significant plasma filament there. It's probably about a dozen Earths in length as it's sort of laying across the northwestern portion of the sun there, kind of laying over the limb. Pretty hard to see depth from this view, but here's the filament in the southeast, rather, as well as that active region. Again, not a sunspot. And the best views are actually in 171 angstroms today. Here's that same region there, and you can see that suspended filament down there in the lower left. And last but not least, the northwesterly filament. It's a good one. It's taller than the Earth is wide. And it's about time to close this thing out. Thanks for tuning in, folks. Remember, stare at the sun, don't drink, no matter how much the government drives you to drink. And if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our links in the description. Support the channel. And may that solar wind be at your back.